So from now on, we're going to look at the code. Okay, so here we have the blaster.h and the blaster.cpp. Um, so, as we can see, some forward declarations here for things it's going to need to interact with. Yeah. So here we're initializing the blaster. I don't have a factory for the blaster. Well, I kind of do. I have the player profiles, which we'll look at that a little bit later. I don't ever delete blasters, and I don't ever delete the bullet. I only have the AI and the regular, so the player profile keeps track of them. But we'll look at that a little later. So here we can see it's making a new bullet. Boom. Setting its wave, setting how many lives it has. Now, if it is AI and it's going into attractor mode, the game manager will call this function to turn the movement interface into AI movement. We'll look at that in a second. The update function just checks if the blaster is active. The next position is calculated by the movement interface, and it's given the speed and the position. And then we use clamping to clamp down the X and the Y to make sure that it stays within the player area. Go over to see that. And it sets the next position, sets the next position for the blaster sprite, and voila. And then the next thing is the draw function. Draws the blaster to the screen. If it's active, draw it. Fire. Sorry, my headset cut out there. If it's active, then fired equals true. Play sound. And the bullet we call the fire function, which we'll look at in a little bit. Is for retrieving the wave for the blaster. This is for activating the blaster, deactivating the blaster, setting a new wave, resetting the bullet. So after it's fired, we contact and it either hits something or the bullet calls this function. If it hits something, the bullet will call this function telling it to reset. Get the position. If it collides with a mushroom, we set a shroom collision to true, which we'll look at how that affects the movement class in a bit. If we die, play sounds on the death. New explosion, subtract the lives. If lives are less than or equal to 0, we call die in the profile management, which we'll look at in a little bit. And otherwise, we just reset the game and reset our position. So then collision, if the blaster collides with anything other than a mushroom, it's going to die, so we just call die. And then get lives just returns the lives. So let's look at the movement. So here we have the base movement face class, movement interface class. I do this with a strategy pattern. It's really simple. It only has one function, move. And in the base, it returns the position. So let's look at the movement class for regular movement. Regular movement, it just has a default constructor, the movement, and it keeps track of the player. So in the move class, we get the speed from the person, get the position from the player, and then we have a couple of if statements, which I know is not very optimized at all, but I wasn't sure about. I didn't want to do the keyboard register or the input register, because if we do the input register, then we can't do hold down keys. So that's kind of an issue. But we check for the shroom collision here, and if it is colliding, then we, in the collision over here, we get the position of the shroom, and if it is colliding, we can't go any closer to the position here. So, yeah. So it then sets shroom collision to false, so that if it stops colliding with the mushroom, it will be set to false. And then this is for shooting. We return the next position to the player. Now, for AI movement, it's a little bit different. So here's the .h for that. Still only two functions, default and regular move. So what I do for this is, in the beginning, I create an array of 8 directions, because there's only 8 different directions that the AI blaster can move. You know, it can move up diagonal, down diagonal, left, right, up, down, and then, yeah. So then, in the movement class, it's called exactly like the other movement class. If the state of stalling is not in effect, which is like when the AI blaster in the game moves, say like that much, it'll stall there for about a second, and then it will start moving again to a different position. So if it's not stalling, then we'll go in here, we'll calculate the movement amount. This checks if this if statement checks if we've reached our destination. It sets stall to true if we have. Otherwise, if we are not, if we still have distance to move on the x-axis, we move on the x-axis. If we need to move the other way on the x-axis, we'll move the other way on the x-axis. You can see if it's not equal, then, or if it's not equal and it's not within 4 pixels, movement points, then it won't move. So the same is done for the Y. We check for shroom collision again. That way the AI can't move through the shrooms. And then this else is if we are stalling, then we have a timer for the stall. We subtract the game frame. Yeah. And the AI player in the online game is always firing, so if player is not fired, then fire. So that just about does it for the blaster. So now let's take a look at the bullet. So the bullet, it's pretty simple. When the player calls the startup function, it gets the where it's spawning at, so the player area, sets up, initializes everything. If we're firing, fired equals true. Behavior is also, or the movement is also done with a strategy pattern. So we'll look at that in a moment. Sorry. This is reset. Behavior is set to follow. Fired is equal to false. If the bullet's active, then we add total distance, which is helped with, which calculates the spider for spider score. We call move in the behavior class, and we set position. This is the draw. Deactivating, we deregister collision. Activating, we register collision. Destroy, obviously we destroy it, but that's never called till the game ends. Then collision, it just calls bullet reset. So let's look at the bullet behavior now. Bullet behavior, this is the base class for movement. Obviously we only have one function in there again, move. And we have 2 sets. We have fire, which if it's fired, then it gets the position, calculates the movement amount, and then shoots. And if the position of Y is not greater than the top of the screen, then it keeps moving. And if so, then it stops. Follow, we just get the position of the current player. and we go to it. That's pretty much it. We subtract a little bit to maintain that image of the bullet being just a little bit out of the tip of the player. Here's the .h for the follow, .h for the fire. As we can see, it's pretty simple things. Yeah, so I'll cut it off, and then we'll do the next segment.